and chloride ion that are permeable, and initially their concentrations are equal on either side, equivalence. It is the X side and it is the Y side. If their concentrations are same initially, then you can imagine that this concentration of chloride ion is more than this side. Protein ion, that is univalent, in this case, electrical equivalence. Initially, on either side they are same. Now, what will occur? Then there is the process of diffusion. Diffusion of a molecule occurs when there are concentration difference between two sides. Here, you have learned in the higher secondary text, the diffusion, or there are some electrical charge difference, potential difference. Then there is movement of the molecule. And in this condition, the chloride concentration is more than in the side, in the Y side, is more than that of the X side. Because some part is taken up the photon. But it cannot pass. It cannot pass. So what will occur? So there is some movement of this ion, chloride ion, following the concentration gradient. Concentration gradient, difference of concentration, and following this, then there is movement of chloride ion from Y side to X side. And along with this, there is some movement of potassium ion, natural tendency to maintain the electrical neutrality. And there an equilibrium will develop. It is called Donnan Equilibrium. And in that condition, the potassium ion concentration on the side X, will be more than the potassium ion concentration side Y. And it will take place. And this total elements on this side is more than the total elements of this side, whatever it may be, ions. That is on the X side, that is this potassium. Greater than so at equilibrium, these concentrations of, and it is the molar concentrations of this potassium, chloride and protein is more than that of the Y side. So in the X side there will be more osmotically active particles. Osmotically active particles. And where there is the scope of diffusion of water, so water molecule may pass from this side to this side. Water molecule. Due to So it will change. It will change. And a new environment will be created, and this process continues. And for this reason, you will find that in the text they say that this volume remains constant. If the volume remains constant and it is not changeable, then this type of effect will occur at equilibrium. And in this condition, Donnan and Gibbs says that this ratio of the potassium and chloride in the compartments in the reverse direction, their ratios are equal. Suppose potassium concentration X divided by potassium concentration Y is equal to chloride concentration Y divided by chloride concentration X. And by cross multiplication, you will find that potassium concentration X into chloride concentration X is equal to they will be equal, and these numerical values on this, they are equal. So it is so you can think it about a rectangle is equal to in area of the square. So there are some, in this case it is more than this, more than their sum. You can remember, if the area of a square is equal to that of the rectangle, then the perimeter of the rectangle will be always more than that of the square. You know that. Suppose if a square is equal to BC, B is not equal to C, then B plus in this way. So it is, in this case it is more than this, more than this. মনে করো যদি এটা 4 হয় 16 18 to 8 plus 2 is greater than 4 plus 4. Moreover, there is also 14. Sum of this is more than sum of this. And also, in addition to there is some equivalence of proteins. So totally osmotically active particle will be there. And in response to this, if there is no boundary, then water will percolate. And cell membrane, our cell membrane of animals, they are thin. We have learned in botany that in case of plant cells, they have a cell coat. they have a cell coat outside the plasma membrane, and that will resist. But this cell coat is not existent in case of mammalian tissue or animal tissue in general. So what will occur? Then its volume will go on increasing, and increasing, and ultimately it is reducing and reducing. And in this way, they all will move, and this side will collapse, and all will go into that side. But it does not take place, because there are some mechanisms of removing these osmotically active particles. Removing the osmotically active particles, and the cell membrane has a marker, that is sodium potassium ATPase marker. Sodium potassium activated ATPase. All the living cell membrane have this membrane marker. Clear? Marker. Sodium potassium ATPase is doing this thing that is done by the cell coat of the plant cells. It is pushing some osmotically active particle from this side. Sodium potassium ATPase, it will act in this way. It will push 3 sodium ion in exchange of 2 potassium. And it is an active process. So that 3 minus 2, that is, some osmotically active particles are constantly being driven away. And in this way, the cell volume is maintained, along with these concentrations of potassium ion or other ions. So whenever a cell becomes sick, then there is swelling of the cells. Because sodium potassium ATPase cannot do function in the absence of its substrate ATP, adenosine triphosphate. ATP breaks down into ADP plus PI plus energy. If I can remember accurately, it is 7.3 kilocalorie. This energy is required to pump this, to maintain this membrane potential. So the cell volume is maintained. And if there is by means of some chemicals, the sodium potassium ATPase, like digital glycosides, it will be blocked. And in that case, there is some swelling of the cells. Another important event in this case of Donnan equilibrium is that there is separation of charges. In this side, there is some increase in the anion. At the membrane level, there is this change. Separation of charges across the membrane. Then membrane behaves as a capacitor. Membrane. Everywhere in this part, bulk of the ECF or ICF, or across this membrane, this part, everywhere the charges are equal. There are no separation of charges. But at the membrane, there is the separation of charges. And so it is called in the living cell, and then there is the membrane potential do develops. Here. And this process that we have discussed, that in the textbooks, they give that they have a volume maintaining shell and then disc. But if they are simply plasma membrane without the action of sodium potassium ATPase, then there is never equilibrium will occur. And all the water will come from this side to this side. But in this situation, whenever this equilibrium is allowed to develop, and there are separation of charges, and there is some increased, there is at the membrane only, across the membrane, there is some negative charge and this is the positive charge. And this magnitude can be known by the concept that is called Nernst Equation, equilibrium potential. And in this way you can find the way that how the resting membrane potential develops, you can learn. Now we can come to the real situation of the cells. Suppose within the cell, it is extracellular fluid, and is the intracellular fluid. And here are some anions that cannot cross this membrane. Protein anions, phosphate anions, they cannot go out. And there is potassium concentration that is higher in this position, and chloride concentration is lower. In the intracellular fluid, this concentration roughly 150 millimole per liter. Chloride concentration 9 millimole per liter. But in the extracellular fluid, the concentration of potassium is much less, 5.5 millimole per liter. And chloride concentration, suppose 125 millimole per liter. Within the cell, sodium concentration is 15 millimole per liter. And outside sodium is 150. Now, this is a condition, and in different books there are some different figures also. But the concept is important. These are extremely easy things, and when you go through book, you will learn this. These are very easy things. Now, due to this, and normally, what is found at this membrane level, then there are some charge difference. And this separation of charges only across the membrane. Everywhere there are equal distribution of charges. Like the border area of two neighboring countries, there are every unrest and every odd things at the membrane. In some cases, there enmity between the two nations, gunfighting may go on, or some drugs or different types of problems will always appear. It is a nature's device, and it is also in the membranes. There is a potential difference across the membrane only. And cell membrane, you know how much thin it is. You can find the dimensions, nanometer. Now you can imagine that in this case the potassium concentration is much more in ICF than the ECF. So following this concentration gradient, potassium will try to move from intercellular fluid to extracellular fluid. On the other hand, due to electrical gradient, it will try to move in this way. And if these concentrations are maintained, then that both these tendencies, that is due to this tendency to move across the membrane due to concentration difference, will be nullified by the tendency of the movement due to electrical gradient. And there is the membrane potential, there is equilibrium potential, there is no net movement of these molecules. No net movements of the individual molecules are traveling, but there are no net movement. There is no net movement. And that is called equilibrium potential for potassium. Similarly, for the chloride ion, due to this negativity, there is a tendency of pushing back of this chloride ion in this way. And due to concentration difference, it is more in the extracellular fluid. So it will tendency to go in this way. And there is a membrane potential at which these tendencies are equal and opposite. There is no net movement of the chloride ion. And you know very well that these ions, they are not in that isolated form. And they are polar molecules. And naturally they are surrounded by the water molecules. And so they are not easily permeable. And for this reason, there are the origin of the membrane proteins, channels, sodium channels, potassium channels, chloride channels, and so. Even for water, there are some aquaporin where quick equilibration is required. And these channels have their selectivity, calcium channel in some cases. And there is movement in this way. And some is more permeable. The membrane is selectively permeable. Suppose it is impermeable to anions. But permeable selectively. It is more permeable to chloride and potassium than the case of sodium. Sodium সহজে ঢুকতে পারে সেলের মধ্যে. Now in case of chloride ion, if you consider, then there is a equilibrium, that is this equilibrium potential, that is ECl minus. Suppose it is, if you call it is the outside O and inside I in this way. You will found that it is the equilibrium potential. potential chloride ion, and it is expressed in millivolt. Millivolt. Energy per mole is considered in this. And it is when millivolt, it is taken as millivolt. Only. And you know these values. R is the ideal gas constant. Gas constant. T is the absolute temperature. Z is valence. Valence. Electrical valence of the sound. In case of chloride, it is -1. -1. Z. And F is Faraday. That is the coulombs per mole. Faraday. FZCl is Faraday. This is this. F is Faraday. And it is chloride concentration outside, and inside Ln is the natural logarithm. Natural logarithm. Natural logarithm is, that is the base E. Base E. Base E. Now you can separate it. You can modify this F ZCl into log you can break down this in this form. In this form. Then you are getting two components, and this part is due to, it is called due to the concentration difference. Potential due to concentration difference. And the remaining part is due to the electrical difference. This difference. So there are opposite function. If there is difference, and you have to consider both this. If you consider inside in comparison to outside, then for concentration, due to concentration difference, the potential should be in that form. Suppose in the concentration studies, that is the RT multiplied by the, that is the log to the base E of chloride concentration inside minus potential difference in this side will be, and it will be equal to 0. বুঝা গেল? এই যে আমরা ফর্মুলাটা দিলাম, এটা হচ্ছে যে কনসেন্ট্রেশন ডিফারেন্স থাকলে পরে তাদের যে টেন্ডেন্সিটা হবে, বুঝতে পারছো, সেইটা এই ফর্মুলাটা দিয়ে বোঝা গেল। When we considering the 1 mole, if the concentration varies, then we have to consider in other ways. Mole per liter we are considering. N is equal to 1 in this way, then we are considering. PV is equal to nRT. Then whenever there is N is 1, we are considering. And in that case, it is the EI minus E0. So in case of chloride, this ECl, if you, and when they are equal and opposite, then there will be no tendency of the molecule. So their sum will be 0. And if you consider this value as this, and then it will come to the other end, and this, there is this negative value, then is this and this negative value, so it will go up in that case and below in this case. Log A minus log B is equal to log A by B. From your basic knowledge of mathematics, you know. So that if this 2 part plus is 0, that is the individual molecules are moving, but they are in tendency opposite direction. So at equilibrium, it may or may not be in equilibrium, but here we are considering that it is in the equilibrium. There is no net movement. So both the tendencies are acting in the opposite direction, and in this way they are neutralizing one another. So in the equilibrium position, what will occur? You will get this type of figure. So if you take this at equilibrium, then you will get M is equal to minus RT divided by, that is the F ZCl. Then it is, if we avoid this sign, if we want to avoid this sign, then there is the reversal of this sign. It will be plus and it will be minus. So it will be log to the base E, then it becomes this chloride concentration at the outside and chloride concentration in the inside. So this is this equilibrium potential of chloride. Now you put up these values, numerical values, and convert this natural logarithm to base 10 logarithm. You have to convert it into a log 10 normal logarithm we are considering. Suppose if you consider this, that is the natural logarithm of A equal to 2.303 into log to the base 10 logarithm. You convert it into the base 10 log, and their numerical values are there, and they are calculated. And in that case, you will find this value as minus 70. And the measured value is the same figure. Now how to know that there is a membrane potential? How to know there is the membrane potential? Then you must have some concept of there is the cathode ray oscilloscope, and it is helpful in this situation. Membrane potential. Potential difference across the membrane, and it is normally expressed at inside in comparison to outside. Minus 70, that is minus on this side and plus on this side. In response to inside, that is the inside in comparison to outside. It is minus. Then how to know this? And this membrane potential is different for different cells. And you can know by the cathode ray oscilloscope. CRO, cathode ray oscilloscope. And the basic function you have learned in the higher secondary text, but you have to go over to that. If it is already not in your text, be considered, you have to see in the higher secondary cathode ray oscilloscope. Cathode ray oscilloscope is that cathode ray oscilloscope is that if there is a cathode and there is the ring-shaped anode. Cathode and there is the anode. Power, there is the power, it is the, and cathode is coming, falling upon a screen. Fluorescent screen. There is some fluorescent material by means of which now there are vertical plates. Vertical plates. Vertical plates. X plates. And they are connected to sweep circuit. X plates. And there are transverse movement due to this. To the charge horizontal, because they are given sawtooth voltage. This type of voltage is created. One is positive, another is negative. Suppose it is positive, it is negative. And electrons are negatively charged. And following this voltage, they will move side. And then there is abruptly stopped and raised again. And so that it will move in this way, and returned in this way. Horizontal move, sweep circuit. It is gradually raised and rapidly it is made zero, and the electron by its negative charge will move to the positive side and then gradually and quickly return to the baseline due to abrupt change, and then again move in this way. In this way, its horizontal movement can be recorded. And there is another is the horizontal plates. And by means of these horizontal plates, suppose it is positive side and it is negative side. And via the amplifier, it is connected to a amplifier. And there are electrodes that ultimately goes to this tissue, or suppose it is the action of a neuron. So whenever there is charge difference, whenever there is no charge difference, then it will move in this horizontal direction. There is no vertical direction. But whenever there is some difference of charge, then it will move. It will move. And this movement may be stable. If there is, or if there is fluctuation, then it can be action potential can be recovered. Suppose when both the electrodes is outside, then there is no charge difference. There is no charge difference. Because at resting condition, there is no activity over the action process of this cell, living cell. And there are microelectrodes, and that can enter into this microelectrodes. 1 μm or less than this diameter, and they can be introduced. And these actions are taken not from the mammalian preparation, because they are very small, but in invertebrate action, they may be 1 millimeter or so like diameter. So they can be manipulated for this type of experiments. Like crabs, squids, cuttlefish, and this type of animals. Invertebrate animals, they contain unmyelinated axons of dimensions that they can be manipulated easily with this type of electrodes. And over these actions, these experiments have been done and they are established. And they can be applied over the functions of the mammalian actions, including human actions, because the behavior of the similar. Behavior is similar. They must be accessible to this type of manipulations, invertebrate actions. And our actions are much smaller, less than 20 μm or so. So how can you do the experiment? But it has been done successfully over the invertebrate actions. Not in our country, but those who are superior to us in this type of knowledge. They have done this and they have established this. And everything has been known by their effort. Now, if both the electrons are outside the membrane, then there is no change and it is the zero in this case. But when one electrode is inside the membrane, you will find that there is a fixed potential difference. Suppose it is minus 70 millivolt, and it is also steady in that sense. So it is the resting membrane potential. Resting membrane potential. There is no fluctuation. Whenever it is on the bottom of the outside, then there is no potential difference. But when one is outside and another is inside, then there is potential difference. And it is a fixed value of minus 70 millivolt. Now we are considering this in case of, that is this, for this ECl minus, equilibrium potential of chloride, and it is same value. So it proves that the physical forces, the process of diffusion is a physical force. It requires no cellular energy, completely passive process, and it can explain the behavior of the chloride ion completely. Now, in case of other ions, it is not so. If you apply this basic concept, then the equilibrium potential of potassium ion, Ek, now in this case, it is simplified. It is simplified by, if you take this value, then it becomes simplified and base 10 logarithm, and these values, numerical values, then it will become 61.5. 61.5 divided by, there is this ZCl and log to the base 10 of chloride concentration outside and chloride concentration inside. And it is the minus 1. So to avoid this, you can again reverse this. Now, if you put these values in millivolt at 37 degrees centigrade, and it is most important because the originally there is the always the T value, and this value corresponds to this value at 37 degrees centigrade. In some textbook they take other temperature, they mention it as 29.2 or so. And this value also changes. There is 60 in 29.2 degree Celsius. But reliable text, they give this value, 37 degrees Celsius. They do not forget. They are superior to us. But you should remember that. When you go through books, you try to find defect in myself. I am a defective man. Unsuccessful defective man. You can find many defects in. And the correction of the defects will enrich your own knowledge. And so you can then put these values. Suppose 61.5 into log, chloride inside and outside. Inside is 9 divided by 125. It will be minus 70 or so. But in case of potassium and the ZK is positive, 1 plus. So it will remain in that position. And 61.5 into log outside 5.5. And you also get a value similar to that, minus 70 milli. Excuse me, minus 90 milli. 90 milli. So it is not equal to that of the resting membrane potential. It is more negative. So when it is potassium, when you are considering the case of potassium, then you forget about the other anions, their function. And if this concentration difference is maintained by any way, then what occurs? Then it should be minus 90 millivolt, but it is not so. Measured value with the cathode ray oscilloscope is minus 70 millivolt. So you can expect there are more at minus 90 millivolt, the tendency of potassium ion to move inside to the outside, following its concentration difference, is equal to that of the in the opposite direction, from outside following the electrical difference, voltage difference, potential difference, equal when minus the intermediate. In case of chloride ion, it is minus 70 millivolt. So it can be explained by these physical processes. But in case of living cells, when it is measured, it is minus 70 millivolt by cathode ray oscilloscope. So you can imagine that there must be some neutralizing effect, some additional amount of potassium ion inside the cell, So it is not the steady state. The equilibrium has not reached. So potassium has a tendency to move from inside to the outside, to bring it to its minus 90 volt basis. So this diffusion cannot explain all the features. There might be. Similarly, in case of sodium, if you consider ENA, is equal to 61.5 log sodium concentration outside divided by sodium concentration inside. It is outside and it is inside to the base 10. So 61.5 log sodium concentration outside is 150 and inside is 50. So it will become equivalent to, that is the 61.5 millivolt, and it is a positive sign. বুঝা গেল? এখন তোমাদের মনে হচ্ছে কঠিন, যখন বই পড়বে দেখবে খুব সহজ মনে হবে। তখন যখন বই পড়বে দেখবে খুব সহজ মনে হবে যে এই সমস্ত লোকেরা এগুলো কেন বলেছে, এইসব ক্লাসগুলো কেন হচ্ছে, এসব তোমাদের উপলব্ধির মধ্যে আসবে। বুঝতে পারছি? হ্যাঁ, যেন গতবারও আমরা ছেলেদের এটা আমরা বলেছি, তারা পরে বুঝতে পেরেছি যে এইসব ক্লাসগুলো খেলো ক্লাস। বুঝতে পারছি? তাহলে প্রথম যখন ঢুকেছে একটু ছোট বাচ্চারা একটু খেলাধুলা করে প্রথম বছর ফার্স্ট ইয়ারের জন্য এই বিষয় আছে। তারপরে তোমরা জ্ঞান যখন বৃদ্ধি পাবে তখন ওই সব ডিপার্টমেন্টে যাবে। বুঝতে পারছি? তখন তোমার এই এনরিচড হয়ে যাবে আরো। প্রথমে আমরা এটা একটু আলোচনা করে নিলাম। ইন কেস অফ সোডিয়াম it is plus 65. If you consider it is plus 60 for easy remembering, plus 60 millivolt. So it is far away, an opposite sign than this resting membrane potential. So it has not also attained this value. Why it is so? Because this sodium ion, hydrated sodium ion form is larger and its channels are less active. At the resting membrane potential, it is less active, it is not open. Permeability of potassium is more than 10 times that of sodium. So sodium ion has little chance of entering it. If the ion is not permeant or very feebly permeant, then it has less scope of bringing its value to the প্রত্যেকে আমাদের কাজটা কি? আমরা সবাই স্বার্থপর লোক, নিজের কোলে ঝোল টানা, সবারই আমাদের আদর্শ তো কি, আমাদের আদর্শ কি, প্রত্যেকে কি করে নিজের স্বার্থটা সিদ্ধি করবো, এটাই তো। And it is supported by physics and nature. Every ion is trying to bring this membrane potential to its equilibrium potential, but everyone has no scope. Potassium has more permeable, so the resting membrane potential is close to that of the potassium diffusion potential. In case of chloride, it is same, because it can be explained by this phenomenon. It has no tendency. But in case of sodium, it is far beyond, due to less permeability of the sodium. So whenever there is increase in the permeability of the sodium ion, then it will rush into, in case of sodium ion, outside concentration is more than inside, 10 times or so. And at the same time, the electrical gradient is also in favor of entry from outside to inside. So whenever there is any scope occurs, sodium will do enter within the cells within a very short time, less than millisecond or so. And it is this generation of this, and it is responsible for the generation of the action potential. Suppose in cathode ray oscilloscope, that it is initially resting membrane potential is this value, but whenever there is scope of sodium to enter, then it will try to bring, it is this, to its value of, it is plus 60 millivolt, but due to something it is 35 stops at this. প্লাস 60 মিলিভোল্টে পৌঁছাতে চাইছে মেমব্রেন পটেনশিয়াল, সে কিন্তু সেটা হচ্ছে না। যেমন আমাদের অসংখ্য আকাঙ্ক্ষা, আমি অমুকটা হব, তমুকটা হব, অমুক মন্ত্রী হব, তমুক, প্রত্যেকেরই মানুষের আশা থাকে, কিন্তু আমরা ছুতে পারি না। সেরকম এটাও নেচারও সেরকম অ্যালাউ করছে যে তুমি অতি সন্তুষ্ট থাকো, ইউ মাস্ট বি স্যাটিসফাইড উইথ দ্যাট। কাজেই whenever the action potential, it cannot go to this value of plus 60, it is plus 35, and you have to return, so it is the action potential do develops.